I had a video about coreboot, and one of the last steps of coreboot is to load the payload. What's the payload? The payload is the software that actually loads the operating system. Coreboot is just to get the hardware ready, get the memory ready so we can load the payload into memory, and the memory can then, I'm sorry, not memory, but the payload can then load the operating system and do all that neat stuff, set up the stuff so that the operating system can talk to the IO and all sorts of really neat stuff. So coreboot actually, despite all its details, doesn't do a whole lot. Once you get to coreboot, nothing happens. Can you see what's going on when coreboot is starting up? Nope. There's nothing in there about talking to the console or doing anything. So if we had a system with coreboot in it, which would be nice if I had a coreboot system, one of these days maybe I'll get one, we would not see anything occur on the screen. The first time we saw something occur on the screen, that would be all up to the payload. So, in order to kind of get a handle on this stuff, what I'm going to do is use a Linux system to kind of show us what's going on and to show something that is closest to the payload. Now, actually, what happens on here is that there's a sector of the disk that I'm using that has the what is it, UEFI format, and that format has a sector just for the bootloader. Rather than in old traditional things, you'd have the master boot record and that would be it. And the master boot record, all that does is go to address 07C0 and start executing. Well, that's way in the past. That kind of stuff doesn't happen anymore. So, what I'm going to do is use this system to show you what the grub thing would look like. So, in order to do that, I have to put this camera on a monitor, and that monitor of the system will show you what you would see pretty close once the payload starts up. And then we can start talking about the grub. So, in order to do that, I'm going to turn the camera. It's got the uh, operating system opening screen there. Okay, can you see that? Yeah, that shows that we have the prompt here where you can start up the Oracle Linux, which is what's shown down here. I really like Oracle Linux. It's got the little penguin down here that you'd expect to see. So I think all these things are pretty cool. So I'm making the video, so I do stuff that's pretty cool. Well, next, I'm going to shut the system down. So I'm going to come up here, do a little power out thing, do the power off, and then I'm going to actually get moving. Now it's totally off. So let's just see what the time it takes. 1, 2, 3, 4, 5. Hey, what do we got there? That was 5 seconds, and we're ready to load the operating system. Not bad. I think Windows takes a lot longer than that, but it's a little hard to tell. Now, see, I hit the escape key before letting it move on, and what we're looking at, it's a big fuzzy duzzy mess right now because the camera doesn't focus very well when you've got the the screen with the high contrast between the black screen and the uh, grub screen. So this is actually grub. But wait a minute. Does that mean coreboot's on this system and grub is the payload? No, I wish that was the case, but that's not the case. What we're looking at is the fact that when the system first starts up, if it's a UEFI system, it looks on there not just to load the boot sector, but it loads a bootloader on there if it's defined. And the bootloader is defined and it's a grub bootloader. Remember, grub stands for Grand Unified Bootloader. Now, I'm talking and you're just looking at a screen, which probably isn't very interesting. So the very next thing I'll do is hit the exit command. And I'll hit enter for the exit command. Two, three, four. Getting ready to load the operating system up. And it's booting the Oracle server. And it's doing some stuff. And let's see what's happening next. And look at the little commands there. These are the commands where it's loading the operating system. See all this different stuff happening? It's actually running, I guess, the kernel, and we're doing all that stuff. And then it's setting up. It's taking some time, but that's mainly for the operating system. So I can't say that the BIOS is particularly fast here. Of course, I don't know what the coreboot time is. So I don't know what that one is. So finally we get going and we stop the operating system stuff that we can see from the command line. And eventually we'll get our Oracle Linux screen coming up. Okay, taking some time here. Where's the Oracle startup screen? There we go, Oracle startup screen. That gives you some idea about the startup process, which is what we really want to look at when we're thinking about coreboot or grub. So grub is the payload. Now we're going to dig into the details of grub by looking at the source code. Source code tells us everything. So here we go with grub. Grub2 was designed to be a bootloader, not a BIOS payload. However, it can be used as a BIOS payload, but the best way to do this is to use a product called SeaBIOS, SEA, like the ocean, SEA BIOS. The SEA stands for Secure BIOS. The emphasis is on the security part of it. Just like coreboot was designed to be very fast and also secure, also that same philosophy goes on with SeaBIOS. So before we actually start the source code of the grub2, I'm going to show you what the execution is at the beginning of the SeaBIOS payload, which essentially loads a secondary payload where we get the grub menu and that kind of stuff. So let's start with the low-level code, the very entry point of SeaBIOS. I'm starting with the very end of coreboot. And if you recall, in the coreboot video, we went through all these different boot states, and I'm pointing out the very last one, which is boot state payload boot. So we're going to do some boot state coreboot exit, a little function there. Then we're going to do payload run. So we're off and running. Now that means notice if it comes down here, then something happened. The boot failed and it didn't work. So, but that shouldn't happen. Everything's running right, correct? Correct. Okay, let's look at program loaders that contains payload run. In payload run, we do some things like boot successful, and we do a little debug statement here to the serial console. Then we load up the entry point, and the entry point is going to be enter elf. Enter elf is going to be our set point that we'll find in just a little bit. Timestamp add now, so we let that self boot jump. We check the stack, one last thing, and finally we run the payload. Now, the payload is a separate binary, and that separate binary that I'm going to use is a binary provided by SeaBIOS. In SeaBIOS, we'll find an entry point for this binary, entry elf. And if you recall, this is the executable format that's used. That's the standard used for this. And notice declare function entry elf. And it also mentions that it's a 32-bit because we were in 32-bit mode when we left coreboot. Now let's see, we do some initialization. Notice we load the stack segments, and we should do something about okay, here we are loading the interrupt descriptor table and the global descriptor table. And there's a address for where all that stuff is put together there. So we can spend some time and look at that too, but kind of the general idea is the overview before we get lost in the details. Come down here, and then we do a jump to C function flat handle post. Now that is, notice it says a C function. So that C function is in our first C file. The first C file is called POST, which is power on self-test, which is the beginning of the BIOS. Notice, remember, there was a built-in self-test on the CPU itself, which we checked. But now we're looking at the power on self-test. And here's the handle post. And that really is the function handle post, which is the assembler transition into the C code. Come up here, here's handle post, and we start doing some real stuff inside the BIOS. Serial debug pre-init, debug banner. Okay, you put a banner on there. And here's a pre-init, make BIOS writable. Now that memory is read-writable, start the power on self-test process. I think that might be enough for this one so that you kind of see this is the handoff from coreboot, entry elf, power on self-test. I'll start another video shortly.